Yay, you came back. All right. So now we're going to talk about what is an integral, which is the second part of calculus. So just as a review, we've already done what a derivative is. So a derivative is basically finding the slope of a curve at a particular point. And the only difference between a derivative and the normal definition of the slope is that we make the uh, run part go to zero. So slope is rise over run, and as the run part shrinks to zero, then the slope turns into the derivative. So now we want to talk about what is an integral. So an integral is going to be related to the area of a graph. Derivatives are related to the slope of a graph, and then integrals are going to be related to the area of a graph. And once again, it depends on how you choose your areas. So do you remember that when we found the slope of a curve, it depended on which x's that we chose? So depending on which x's you would choose, you could get different kinds of slopes that would go through the same point. But as the x's got closer and closer together, then the slope became the true slope for that curve. So similarly, we have to be very careful about the areas that we choose. So in general, okay, area is going to be equal to like width times length. So this thing here, let's say that's your width. And then you're going to multiply that by the length. So width times length is area. So we're going to be multiplying the up and down part times the sideways part, and then that gives us a rectangle. And then that would be the area of it. So the up and down part is the y. So we're going to, for this function right here, it's going to have a certain value of y. So that's going to be the height. And then the sideways part is going to be the x. So if we wanted to find the area of this curve, we could take like this area right here, and then let's say that we could have this area right there, and then maybe we could have this area right there. Okay, so you have this rectangle, this rectangle, this rectangle, and then when you add them all together, so let's put in one more here. So let's put this one in there. So if we added the areas of this rectangle, this one, and this one, it would approximate the area of the graph. But it's not a very good estimation because look at this. So this part right over here, we overshot it right there. What about this part right here? You see how that's not being used. And then similarly, this part over here and this part up here. So you can see that there's a lot of error in doing that. But in the second one, the green one, what we've done is instead of using these very large lengths, we used a smaller length. Now the bad news is we have to have more rectangles. So the smaller that we make our x's, or the lengths of each of these little rectangles, as that gets smaller, it means we need to add more and more rectangles. But the good news is it gives us a better approximation for the area under the curve. So when we did it up here, we had to have the delta x go to 0 in order to find the best slope. We're going to do the same thing. So we're going to want to have in the limit, as this distance here gets smaller and smaller, it's going to go to 0. You're going to have an infinite number of rectangles. And so the integral, so this is going to be our symbol for integration. So that's the integral of y and then dx. So notice this is going to be the height of the box, and then this is going to be the sideways part. So when we multiply these two things together, that's the area. And it's going to be equal to, now notice there's another limit. So this is the limit as n goes to infinity. N is going to be the number of boxes that you have. And then it's going to be the sum. So we're going to need to add together all of these boxes. And then each of the boxes is going to have a certain width, and then it's going to have a certain length or height. So this is going to be this is the definition of what an integral is. And then this is the definition of what a derivative is. Now this is where it gets really, really bad. I'm not even going to show you a worked out example of trying to solve a formula using this, because it involves using what's called an infinite series. And you can look that up on Wikipedia to find out what it is. But it's nasty. And so mathematicians don't really use this very often. But what they have done is they have worked it out in detail for, again, several different formulas. So here's a table of different kinds of integrals. And this is what you use. So if you're a mathematician, you don't use the definition to solve these mathematical problems. You already know what the integrals are. So those integrals there have been worked out using this technique. And then once we got the formula, then we can just use that formula over and over again. So let me give you an example of how we might use this. So here's a sample calculation. So y is going to be equal to x squared. Find the integral of it. So we want to find the integral of y dx using this table. Okay, so first we're going to write down our, let me erase some of this here. Okay. Enjoying your cup of coffee? I hope you are. All right, so back to our lecture here. So the formula that we want to analyze is y is equal to x squared. We want to find the integral of y, so let's plug in x squared and then dx. So that's the thing that we need to solve. Okay, so how are we going to solve it? So we're going to go back to this one, and we're going to find the equation that goes with it, which is going to be this one right here. So this equation is the one that we're going to use to solve the problem. And it says that the integral of this thing is going to be x to the n plus 1. So this thing here, that 2, is n in the general formula. So we're going to be using that formula there. So if this thing was n, then it's going to be x to the n plus 1. and then we're going to divide that by n plus 1, and then there's going to be a constant on there. So let's go ahead and evaluate this. If n is equal to 2, then 2 plus 1 is 3. So this is going to be equal to x to the third power, and then what is 2 plus 1 is going to be 3. So you get x to the third over 3 plus a constant. And that constant, you have to know what the initial conditions are for the formula in order to figure that out. And I'm going to show you what I mean by that in the next video. Okay? All right, let's keep going here. So let's take a break, and when we come back, I want to show you that the derivative and the integral are inverses of each other. So I'll see you in just a moment.